The following videos are of Brunauer, Emmett, and Teller. The Brunauer video was made by Arthur Adamson before television in 1970 at a meeting that featured polywater.
All right, now we start talking about polywater.
Okay, go ahead, Bob.
And the question is it the magneto-optic effect of 1970?
All right. I think it's a great legal question of the century. Yeah, do it, get somebody to decide what the rules of evidence are.
And what also seems to me quite striking is of all of the people we're talking about the polywater, it's highly questionable whether any two of them have made the same material.
Well, it is highly questionable. And even the same man, whether the same man made the same material.
The second video is from a Johns Hopkins University TV broadcast in 1959 showing Emmett and Jane Phillips, who became the first female chemical engineering professor at University of Toronto.
Measuring the surface area of finely divided or porous solids. This method is called the BET method and is named after its originators, Drs. Brunauer, Emmett, and Teller. Perhaps the principal application of the BET method has been found in measuring the surface areas of catalysts. With the help of this method, chemists are now able to estimate the available surface of a catalyst and to judge whether changes in method of preparation alter the quality as contrasted to the quantity of the catalyst surface.
The third video is one that I made of Teller at Stanford University in 1989 with him describing the development of the BET theory.
Steve Brunauer showed me an explanation of this multilayer adsorption, which was based on forces between the surface and the adsorbing atoms acting at a considerable distance. And from what I knew, what was generally known by that time, on the interaction of molecules, it was quite clear that this explanation could not hold. And Steve was quite ready to accept that negative statement, but he also insisted that here are data about the multilayer adsorption, which needed some explanation. I suggested that this should be done, precisely as Langmuir has worked on the monolayer, on the single layer adsorption, with the only difference that the first layer would then adsorb the second layer. In other words, that the solid does not exert distant forces on the further layers, but that it would be the same kind of interaction repeated, not between the solid and the first layer, but now between the first layer and the second layer, and later between the second and third layer, and so on.